Hey everyone, Leo's here, another Johnson Lightning episode. I'm excited about this one. I have Nabeel here with me to talk to me about a lot of cool things with IoT. Stay tuned. Hey everyone, Leo's here, another Johnson Lightning episode, and I have Nabeel here with me. Nabeel, how are you doing, my friend?
I'm fine. How are you?
I'm good. I'm excited to have you here. We've been trying to get this on the books for a long time now. We wanted to do this episode because you did a lot of cool things when it comes to IoT and LoRaWAN protocol. So I wanted to talk to you about that today. But before we go and nerd out on all this type of stuff, Nabeel, who you are, what is it that you do?
Yes, my name is Mohammed Nabeel. I'm a principal engineer at Microsoft. The organization that I work for is Azure CXP. I'm proudly part of the Azure Fast Track team.
So, Nabeel, we've been seeing a lot of things coming in the IoT space. I had multiple guests on the show talking to me about that. We did like an IoT operations series and in the past, and there's a lot of things going on. And just kind of to share with you, this is not my background. Like, I'm not coming from an IoT background, I guess not proper IoT background throughout the years, but I am starting to get sucked into this, like more and more. And when I started talking to you about some of the things that you've been working on, I got really excited because that showed me like another angle of, use cases that I haven't thought about. So that's why I wanted to have you here on the show. So let's just nerd out on all those stuff. Like, what is this thing with IoT and LoRaWAN? Can you maybe explain me?
Yes. So as you can see, as you know, the IoT is a technology that we use for connecting devices, right? And when we talk about devices, there are different types of devices that come into play. There are some devices that were developed, built, and deployed way before any cloud technologies were even conceived, right? And they are using some different protocols for all those devices. And one of those set of devices that we see in the industry, especially in oil and gas and environmental protection agencies and things like this, they use devices called LoRaWAN. And LoRaWAN devices are devices that use a LoRaWAN protocol to communicate, to gather data. These are low-powered devices that do not require a lot of care in the sense that you don't have to keep checking on them every day. They are deployed in the field, and they are supposed to work for without any interruption for, let's say, 10 years. The battery life is provided, and for those 10 years, they will keep on working what they are doing. One big example is that, for example, there might be a LoRaWAN device that is out in the depth of Amazon jungle and just collecting weather data and transmitting that data to the gateway, and then from the gateway we collect the data. So there is a big need there that we talk about those devices and have find new ways to leverage the data that's coming from those devices and build AI models or any other things that we can do with those devices.
Got it. So, it's kind of interesting because when we were talking about edge computing, it's kind of become some sort of a generalized term, right? And when I'm trying to break it down, like this edge computing notion, I think that there is edge computing in the sense of, a data center, massive operations and all of that. There is edge computing in the sense of, branch offices. I think that what you're describing here is almost like a far edge, like things that are not actually accessible or reachable or not designed to be touched on a daily basis. And I also like the notion of harvesting this type of stuff for research purposes, because that's another great use case here.
Absolutely. And I would say they are far edge. At the same time, in some cases, they are part of the edge as they bring data into the edge platform. Like, for example, in this demo, what I'm going to show you is that there's a LoRaWAN device that talks to Azure IoT Operations, which is an edge device. So it is complementing that. And the idea is that how we can complement the edge and make the edge more relevant. So this makes it more relevant that it has the access to far edge devices, as you mentioned.
I love it. Show me the magic.
Okay, so what I'm showing you right now is just a quick definition of LoRaWAN. What is LoRaWAN devices? We just talked about this. I want to talk about real quick on the architecture and how a typical LoRaWAN solution is implemented. There are three parts to this. There are three things. One is the LoRaWAN device, which you can see here on the on the left side here, right on the
Mhm.
diagram. Then there's the gateway, and then there's the network server. So what happens is that the actual data is gathered by the device, and we call it LoRa device, right? It talks to a gateway, which it can have one gateway, it can have multiple gateway, but basically it communicates to the gateway. And the gateway is the connection of that device to the outside world. Gateway is typically what it does is that it sends the data to a particular protocol on a particular IP at a particular port, and then there are network servers which basically which pick up their data, and then they attach it to different applications, cloud platforms in some cases. So this is pretty simple. We have a LoRaWAN device, and then there's a gateway, and then there's a network server. The magic here is that the gateway is the one which connecting all the devices, and it's sending the all the data to network servers. So before delving into the solution that is built, I'm going to go ahead and talk about real quickly on where we use the LoRaWAN devices. As I said, we use them in smart cities. We use them for valve placement, like a small, if in the field, if there is a device that is looking to see if the valve is on and off. We see LoRaWAN devices, again, far edge logistics and transportation, where it's mounted
Mhm.
on trucks. We use them. We see them in power control for voltage monitoring and current consumption. Again, it's working to collect the data. Acoustic monitoring. So this is from the environmental protection perspective, from sustainability. If there are facilities that are built or factories that are built in far remote places, and there's a concern that the noise that they are generating, we see LoRaWAN devices are deployed there to monitor the noise that they are making, to make sure they are not they're not causing the noise pollution. And then we also see them a lot in the smart agriculture. Okay, so these are again very a wide spectrum of the devices that are using the LoRaWAN devices. Now
You
let's
know,
get yeah, go ahead.
Nabil, just before you dive in a bit deeper here, what is the like? I wanted to ask you, just kind of based on the work that you're doing, what are the use cases that you see this thing used the most? Like,
Yeah, so the most of the use cases I'm seeing is for oil and gas companies, especially that I work with, and
mm,
they are out in the field. Like most of the oil and gas installations are remote. They are far from cities, from metropolitan
yeah,
population centers. They have weird sometimes internet connection, and connectivity is not good. So that's why the LoRaWAN devices are so cool, because it's low powered. Like they don't require a lot of power. As I
yeah,
said, the device is like supposed to keep working for 10 years and collect data. And the other thing, one more thing, is that it's not uh, used in life critical places, like or a situation where basically we really need to have the data in certain time. It's a little bit like on less on criticality, but more on getting the data
mm,
for certain places. So
got it.
let's say there's a LoRaWAN device. If it doesn't give a temperature reading in 15 seconds, no problem. Next 15 seconds will give you the data. So those are the places where we use the LoRaWAN devices.
Gotcha. Okay, cool.
Cool, awesome. So what I've done is that I'm going to talk about the solution that we are talking about here, which is the LoRaWAN with Azure IoT Operations. As I mentioned before, there is always this need to bring data from different data profiles, from different places, from different type of devices to edge, to IoT operations, for example. And this is one of the effort, is to see how we can see the data coming from a LoRaWAN device, how we can get that data into our Azure operations. I'm just going to go over very quickly on the architecture and what we have built. And it would seem similar to what the architecture I was showing you before on the previous slide, where we were showing the LoRaWAN device, and then LoRaWAN gateway, and then the network server. So this is similar, but it is basically for Azure IoT operations. So there are four things here on this architecture which are critical. One is the LoRaWAN simulator. So what we have done for this demo is that I've prepared a LoRaWAN simulator, which is a real simulator that is generating LoRaWAN data, right? And in it, there is a LoRa device at the bottom, which is connected to a gateway. I will show you that gateway. And then there is the gateway bridge. So this is the gateway bridge that is transmitting the data that is being generated by the LoRa device at the port 1700. So this gateway bridge is continuously sending the data on this port, which is being generated by the LoRaWAN gateway. And then what we have done is that we have built a custom LoRaWAN broker. And this broker is listening to that UDP data that is being generated by the gateway. And then it is listening to it, and then it's publishing to a broker listener. Broker listener is kind of like a bridge that allows us to talk to IoT operations. So I'm going to show you that how that bridge is working. And then on the Azure IoT Operations side, I'm going to show you how the data that is coming from the LoRaWAN, we are seeing the data on the Azure IoT Operations using the MQTT UI interface that we have there. So this is, in a nutshell, this is the simple architecture that we are going to implement, going to show in our demo.
I love it. I think it's pretty cool to see that you can actually simulate this type of stuff end to end, generating LoRaWAN data or LoRaWAN oriented or base data. I think that it's kind of cool to see. I was wondering, and I, we'll see that through the demo. I mean, I'm curious to know if there is any way to simulate the, the milliseconds or the latency, what I mean, like when it comes to the data transfer, but I'm excited to see the demo.
Yeah, absolutely. Okay. So we'll start off. I'm going to go ahead and show you the simulator. So this is the simulator. It's called LWN simulator that I'm using for generating the data here. And very quickly, I want to show you the components that are part of this simulator. So this is the dashboard. I'm going to go ahead and show you the devices. So what I've done is that I have built, I created a device here, which is a virtual device here and called LoRa device. That's at the bottom. This device is talking to a gateway. And the gateway here name is LoRaWAN Gateway Virtual Gateway. This is a simple gateway that I have declared here. And then this is the gateway bridge. And notice here the port and the bridge address. So this is basically how we tell the LoRaWAN gateway, the simulator to where to send the data. So as it's simulating the data on for the LoRa device and the gateway, where it is sending to this address. And from there, we will pick up that address through the LoRaWAN, the broker that is a custom broker that's written, and then we will show on the other end how data is coming. So we've seen the LoRaWAN simulator here. I'm going to go ahead and show you the. So this is the port forwarder. What's going to happen is that this is the port forwarder, which is basically getting the data from the LoRaWAN custom broker, and it is going to forward to Azure IoT Operations. And I have actually different components for each of them. This is the LoRaWAN gateway data that is shown on the MQTT UI. So I'm going to go ahead and show you. So this is how the data is when we start a simulator, you will see the data start coming here as well. I want to mention here also very quickly, this is the IoT operations. So you can see the data that's coming to Azure IoT operation. We can see it here too. So in my case, for this demo, I have an IoT operation instance running with one device, which is called Boiler. So you can see that if you all the data that's being generated for that device, you can see it here. So this is the Azure IoT operations portion, and this is the LoRaWAN gateway portion that we are working with. So what I'm going to do as a next step is that, show you how the broker is going to work. But before that, I want to also show you this. This is the LoRaWAN simulator console. So whenever the data is generated from the console will get updated, and then we will see the data on the broker side. So I'm going to go ahead and run the broker. Okay, so right now the broker is running, and it is waiting for port 1700. And I'm going to go switch to the LoRaWAN simulator. I'm going to go ahead to the dashboard and start the simulator. So what will happen is, right now the status is red. As soon as I run the simulator, the console here will start showing the data that it's generating the data, and on the other end, we will see the data coming in. Okay, so I'm going to go ahead and run the simulator. You can see it's on, and it is sending the data, and it says that LoRaWAN gateway is on. Now, if we go here, the broker has received the data. It has received the data for two data items, and as you can see, as the data is generated, it is publishing the data. And This is the console. So as this updates the data, we will see the data coming to the Azure IoT Operations side. So I'm going to go ahead and show you. So this is the Azure IoT Operations. As the data is coming in here from the simulator, you can see here the new data will come in and post here. So this is how the data from the LoRaWAN simulator goes through to the broker, and broker uses the port forwarder, and it's basically doing the MQTT update to the IoT operations, and it sends to IoT operations.
Yeah.
And on the MQTT UI, you can see the data coming in.
It's always interesting to see how data is coming in from different sources, and how it looks like before you start to contextualize the data. Like and we talked about it in previous episodes. At the end of the day, this type of data streams, right? They can come in so many different shapes and forms, right?
Yes.
Especially when you talk about things like topics and subjects, and MQTT, and in different protocols. Like in different protocols, talks in they have like different outputs, and that's really interesting to see how that data is coming in. I wanted to ask you, Nabeel,
Yeah.
when it comes to this solution, like the architecture and all of that, how difficult it is for someone to actually architect these type of solutions. Like what are the things that you will say that they need to watch for when approaching this type of stuff?
Yeah, so the most important thing I would say is making sure that you see the architecture of different pieces, right? Like different components. Like when I saw the architecture on the very first screen, which I was showing you with the network server, I saw the components there, right? And I said, what I did was that if to myself, if I can simulate the LoRaWAN data coming from a gateway and a device, and I can see the data coming in. So when I was working on the solution, I actually installed a Wireshark and different softwares and run on the machine while the simulator is running and seeing the data coming in. So I think the most important thing is when you are when you architect something like this, just make sure you know the data source and then how that data source will pass on. So once I had the data, then for me, it was like, okay, how can I push it to Azure IoT Operations? That's where the broker, the port forwarder that I mentioned, it comes in the picture. Then it also meant that I need to write a custom broker, which basically picks up the data coming from the LoRaWAN, and then I can push it. Right. It then makes its own way, I would say, like water and flows through the gravity. Wherever there is a gravity, there's a depth. Water will find the way.
I love it. I'm loving it. And just a quick anecdote before you're showing me how to get started with all of this. Those were two blessed from the past. When I'm looking at the screen, I'm looking at Putty. You mentioned Wiresharks. I just want to point out that this is like blessed from the past, for me. So appreciate that. That ride in I guess nostalgic tunnel here. So
no problem. Yeah. They work. Yeah, I would say
definitely work, and it is disclosing our age, so we can move on. Nabeel, one of the things that I was super excited about is the fact that you actually contributed this entire thing to Jumpstart Drops, which we launched back in May. So can you show me how does that look like?
Yeah, absolutely. So my pleasure here. So and I recommend everyone, not a shameless plug, to always look at the Jumpstart and drops and leverage things. There are so many amazing things out there. So if you go to the Jumpstart website, you would see here, if you scroll down, there is the LoRaWAN with Azure IoT Operations drop. And if you click here, you can see the details. And if you see the architecture, this is exactly the same architecture that I shared with you. So take a look at the LoRaWAN, this drop, and go and visit and download it. And once you download this, if you want to see how the complete solution README, how this works. So this is the complete the GitHub page for that this refers to, and you can see this has complete detail on how you go from zero and implement the whole solution. It starts with what are the prerequisites, and then there are solution build steps that I mentioned, and starting with you're having a Ubuntu machine, and then what you need to install on the Ubuntu machine, and so you can prepare it for Azure IoT Operations. So you can use this to also as a guide for the Azure IoT Operations there. And then how you deploy the simulator. So this was one of the most important aspect of this solution, was how you get a LoRaWAN simulator up and running on the same machine where you have Azure IoT Operations running. So this is the same. This was a little bit more tedious work to do, but I was able to find all the steps here, and these are the steps. You just need to go to the repo that you will download and run these scripts. These are the steps there, and then also how you set up the LoRaWAN simulator. As I mentioned. When I was showing you the demo, there was the gateway bridge there. So these are the steps how you assign the port and the address to the gateway bridge. This is that step. It will show you. So for each step, the screenshot is there. You can go and look and follow. So this is how to create the device, and this is so the device is saved, and then how you configure the virtual gateway that I was using. So all those steps are here. And then how you deploy the MQTT client, that's what I was using to push the data to Azure IoT Operations. And this basically shows how the data is coming there, how you deploy the broker listener to do the port forwarding. That's part of the solution. And then how you run the LoRaWAN broker that I showed, and exactly the same thing you can see here on the screen. It's waiting for port 1700, and then it is publishing as the data is coming in. It's publishing, and this is one of the interface. This is the one on the Ubuntu machine screenshot, but it's the same thing, same data that's being shown here.
Loving it. I think that Nabeel, when I see these type of bundled examples, that's really where I get jazzed up, because I think that there is a certain art to actually taking something complex and make it simple, in the sense of you can consume it and you can actually evaluate and you can try it, which is really the spirit of what we do in the Jumpstart. And I'm happy that that you are able to just kind of bundle this solution that in real life is a very complex architecture, but you are able to just kind of condense that to a small footprint and being able to bundle this. And I'm excited about the new things that you are coming up with, which I know you are. So excited about that. Thank you, Nabeel, so much for being a host here in Jumpstart Lightning. And for the Jumpstart audience, make sure to like, subscribe. More cool stuff are coming, and we're going to see you in the next one. Bye, everyone.
Awesome. Thank you.